For this system of equations, it's telling us that we can solve by using any method. So we can use either graphing, we can use substitution or elimination. So in this case, I notice that there is a y that's by itself. So since there's a y by itself, this might be a good problem to use by substitution. So I'm going to do this problem by substitution, purposely solving for the y in the first equation because we see it's isolated. If I try and solve for something else, I might involve fractions. So I think it's easiest to solve for take the first equation, and I'm going to solve that one for the y. So I'll take the first equation here, going to add y to both sides, and I get 3x equals y plus 4. Then I'm going to subtract 4 from both sides. So I get 3x minus 4 equals y. Now that I've solved for y, I want to put it into the other equation. Don't put it into the first one, otherwise everything is going to cancel out. We'll put it in the second equation. So I have 6x minus 2 times 3x minus 4 equals 7. Okay, so now I've eliminated the y, so now I have just x as the main variable, so I can solve for it. That's what we'll do next. 6x minus 6x plus 8 equals 7. The x's cancel out, and we get 8 equals 7. So you might be thinking, uh-oh, did he make a mistake? Well, the answer is no. Actually, there's no mistake that was made here. We get an interesting result here. We get a statement that's actually going to be false. Okay, 8 does not equal 7. So if you get a false statement, then that means that there's nothing that actually makes these equations will ever be the same. So in this case, what we're going to put is we need to put no solution if we see a false statement that comes up. Now, let's suppose that we went through all this and we solved all of it. And let's suppose we got like 8 equals 8, or maybe we got 0 equals 0, something like that, where it's a true statement. Now, if we get a true statement, then we have a situation called infinite solutions. So that's kind of gives you both different options. So in this case, we actually would have a case where both these lines would actually be a parallel. So that means that they would look like this, and parallel lines, if you were to graph those, you would see that it would look like this, where they might be slanted the other direction. So either way, you'll see lines that are going to be parallel that will not cross like that. And so that's what's happening here. When you've got infinite solutions, that means you've got one equation on top of the other one. Now, again, it may be slanted the other direction here, but the main thing is you've got one line drawn on top of the other line. And so it ends up being infinite solutions because every point on the first line matches all the points on the second line. So that's why no matter what you solve, you always get a true statement no matter what. So in this case, for this problem we have here, it would be no solution because we got a false statement. They'd be parallel lines in that case. So again, there's the two different situations. If you get a true statement, it's infinite solutions. If you get a false statement, that means it would be no solution.